All right, Algebra students, Mr. Peterson here, and we have another day of remote learning. So I'm going to be delivering a lesson to you guys through a video. Today we're going to be doing lesson 5.5, and as we go through here, when we get to the end, if it doesn't make sense or you're unclear how to do the assignment, please reach out to me. You can email me. We can also set up a time to do Zoom, and I can work through some problems with you. So let me know. I'm here to help you guys out if you need it. Okay, so what we're going to do today, this is our last lesson that we have in Unit 5, and we're going to solve a system of linear inequalities by just doing some graphing. All right, so we graphed linear inequalities in Unit 4. It would look like this, like y is greater than or equal to 1/2 x plus 5. Okay, so there's an example. When it had this type of symbol, you guys may remember we did some shading on our graph. So we're going to be doing some shading, some coloring today. And today you're going to need two different colors to use. It doesn't get much more exciting than that for our shading that we're going to do. Okay, so let's take a look at our first problem, our first system that we're going to end up graphing and solving here. Okay, so here is our first system of linear inequalities. We got two of them. We have y is greater than or equal to 3 over 2x plus 1. And then we have y is less than 4x plus 3. So we're going to put both of these lines on this graph, and we're trying to find the spot where these two lines would cross, just like we've been doing in Unit 5. But we're going to do some shading also. Okay, so when we go through and we get done, we're going to find two ordered pairs that are solutions and two ordered pairs that are not solutions. It's kind of similar to what we did in Unit 4 when we were just graphing these things here. Okay, so to graph anything, any line, it needs to be in this format. Y equals mx plus b. It has to be in slope-intercept form. So that's what you want to check first. Check to see that both of these are in slope-intercept form, and they are. So we're going to go ahead and start graphing them. All right, so let's graph our first one here. So we always start with this number at the end. That is your y-intercept. So our y-intercept is at positive 1. So we would put our first point on positive 1. All right, and then this number, this fraction next to x is your slope. Okay, it's a positive slope. So our line is going to be pointing to the right side of the graph. It's going to be going up this way somehow. All right, and our slope is up 3 over 2. Okay, so starting from this point here, we're going to go up 3, 1, 2, 3 over 2, up 3 again over 2. Okay, just like we've been doing for like several times this year, just regular graphing of a line. Okay, we got a few points. Now we're just going to connect those points together to end up making a straight line here. All right, so if we graph those, okay, it would end up making a nice straight line, something kind of like that. All right, and then now we want to graph, we got something else to do here for this one. So because it's an inequality, just like we did in Unit 4, it involves some shading. Okay, so take a look at your y. It's telling you y is greater than the line. Okay, so your y is larger. It's greater than the line. All right, so if you take a look at your line here, and you look at your y-axis, all your values up above the line for y show y is getting greater. All right, and all of these values down below show y is getting smaller. So we want to shade this entire area up above the line to show that y is greater, it's above the line. Okay, so now we're going to do some shading here. So get your colors ready, get excited. We got a little bit of shading here to do. We'll go with some pink. Okay, so we're going to do some shading. We're going to shade everything up above the line. Okay, there we go. Get some nice shading going. Okay, perfect. Okay, so there is our first line, and we got it shaded correctly. All right, let's take a look at our second line here. Okay, so our second line, we have y is less than 4x plus 3. It's in slope-intercept form, so let's start at our y-intercept at positive 3. So we're going to change some colors here. Let's go with blue. All right, so positive 3, that's going to put me right there. Okay, and then here's my slope. I don't have a fraction here, so I'm going to put a 1 underneath of that 4. It's a positive slope, so it's still going to the right. And I'm going up 4 over 1. So from this right here, I'm going to go up 4, 1, 2, 3, 4 over 1. Okay, and then I don't have room to go up 4 over 1 again, so I'm going to go down 4, 1, 2, 3, 4 over 1, like that. Okay, so I got a few points. Now, before you make a line, take a look at this. We covered this in Unit 4. Because it doesn't have the equal to part, it's going to be a broken line. All right, it's not going to be a solid line like this one because it doesn't have the equal to part. So this one's going to be a broken line. All right, so let's make a few more points here so we can see where exactly our broken line is going to go, because sometimes it's kind of hard to tell. Okay, so we got that. All right, so we got enough points. Now let's go ahead and connect them with a broken line. Okay, we'll put some arrows on there. All right, like that. Okay, so there we got that line graph. It's a broken line. Now we need to do some shading here. All right, and our shading, so it says y is less than the line. Okay, so y is going to be smaller than this line. So find your y-intercept, which was right here. And if we go this way on the y-axis, y gets higher. If we go this way on the y-axis, y gets lower. All right, so we need to show that y is lower than this line, this broken line, because our y is less. All right, so we're going to shade everything underneath of this broken line, everything in this area. And when we do, we're going to be overlapping a little bit with the area that we already shaded. Okay, and that's what we want. So here's what our shading is going to look like. We're going to shade everything underneath of this blue broken line. Okay, so if we do some shading, all right, all of this area is going to get shaded here. Okay, so we got our shading done. So now we're done. We got those two lines graphed. So now let's talk about where our solutions are. So this blended area where these two colors came together, anywhere in this region represents solutions to this system. Anywhere where those two colors overlapped and blended together. So if I want to name two ordered pairs that are solutions, I would just pick any 2 points that are within this region. All right, it doesn't matter what 2 points you pick, you just want to pick any 2 points in that region. All right, so let's go ahead and name some solutions here. So we'll say yes for solutions. Okay, so we'll go ahead and name these two ordered pairs. So I picked 1, 4. And my other solution was 3, 6. Okay, so there are two solutions that would work. Two ordered pairs that are solutions. Okay, let's take a look at no. We have lots of options for no. It can be anything that is outside of the area that was blended together. So it could be out here. We could be way down here. Anything outside of that blended area. Okay, so for no, I had 5, 1. And then I also have, let's see, what do I got over here? I have -8, -4. Okay, so now we answered all parts of that problem. We graphed the two lines, graphed the two inequalities. We found two ordered pairs that are solutions, and we found two that are not. All right, so that's what we're up to today. We'll practice this some more. Hopefully that worked out okay for you. Let's take a look at our next problem that we're going to do. Okay, so here we got this one here. And if we're going to graph both of these, all right, in order to graph them, they need to be in slope-intercept form, y equals mx plus b. Okay, so if we take a look, our top one is ready to go. Our top one's ready to graph, no problem, because it's in slope-intercept form. This bottom equation is not ready to graph in its current format. So what we need to do is a little bit of algebra to get y alone and everything else to the other side. Okay, so really I want this y left here, and I want to move minus 3x over here. Okay, so just like we've been doing, we can move it using algebra. So we would cancel it by going plus 3x, and then we would go plus 3x to this other side. Okay, so that cancels it off. And then now I'm left with y, keep your same symbol, and I want x to go first, so I'm going to put positive 3x first, and then my minus 2 after it. All right, so now we got the bottom one in slope-intercept form. The top one was already in slope-intercept form, so let's go ahead and get both of these graphed. All right, let's start with the one on the top. So we'll go with our y-intercept, which is positive 6. Okay, so we put a point there at positive 6. And our slope, we have a whole number, so throw a 1 underneath of it. And our slope is going to be up 3 over 1. All right, and before we do that, take a look. They both have the same slope. Okay, so something's going to happen with these two lines. Keep that in mind as we graph them. Their slope is both the same. So this one, it's a positive slope. It's going to go to the right. And it's up 3 over 1. So from here, we're going up 3, 1, 2, 3 over 1. All right, can't go any further up, so I'm going to go down 1, 2, 3 over 1. And I'm going to put a few points because this is going to be a broken line because it doesn't have the equal to part. All right, so I get a few points down, and it makes it easier to see where this broken line is going to go. Okay, awesome. So I got points all along that graph. So now I'm just going to draw a broken line. Okay, and I put my arrows on there like that. Okay, so there's our first one graphed. All right, let's take a look at our second one. Second one, we're going to be starting at negative 2. And we have a positive slope, same as that one. We're going to put a 1 underneath of it so we have a slope to work with. We're going to change colors. All right, we'll go with blue. Okay, so we're going to be starting at negative 2. All right, and then my slope is still positive, up 3 over 1. Okay, so up 3, 1, 2, 3 over 1. 1, 2, 3 over 1. 1, 2, 3. All right, and I could put another one up there. Follow the same pattern going down. All right, and if I'm putting these too fast on here, you guys can pause the video so that you have time to put your points on. All right, it's going to be a broken line because we don't have the equal to part. Okay, so let's make a broken line. And can you guys see what's going on with these two lines? All right, are you noticing that they're parallel? Because they have the same slope, they're going to be parallel. All right, so now, we forgot to do the shading on the first one. Okay, so let's go back and take care of all of our shading here. All right, I didn't get that done on that red line. I apologize. Let's go and get that shading taken care of. All right, so our shading. Let's see, so we're starting with our first line. So this one is saying y is less than the line. So if I take a look at my red line, I want to show that y is getting smaller. It's below my y-intercept of 6, so I need to shade everything underneath of this line, okay, because y is getting less than the line. Okay, so we'll do some shading here. We're going to shade everything underneath of that red broken line. All right, it's going even over top of this. That's fine. It's going over top of our blue line. That's okay. Okay, so we took care of all of our shading for the red. Okay, and now let's take care of our shading for the blue. So this one says y is greater than the line. So if we find our y-intercept of -2, we want to show that y is getting greater. So we want to shade everything above the line. Okay, so, oh, we need to get a color change here. Undo that. All right, blue, here we go. Some overlapping color. Oh yeah, that looks nice. All right, there we go. We got some shading going. We'll shade the rest of this region. Okay, perfect. So we got our shading taken care of. Now let's take a look at what we want to do. We want to describe the solutions. Okay, so describe what's going on here. So my solutions to this, the blended area happens to be in between the two parallel lines. Okay, so that's what I want to describe. Instead of naming some solutions, I just want to describe this region. So I'm just going to say in a short sentence here, the solutions are in between the parallel line. Okay, so we'll just write that down. Solutions are between parallel lines. Okay, something like that, just to describe where those solutions end up being. All right, so now we got this one completely taken care of. All right, let's take a look at this one here, and we will get this one graphed, and then we'll end up describing what these solutions would be. So to graph any of these equations, it needs to be in slope-intercept form. All right, y equals mx plus b. So if we're taking a look at both of these linear inequalities, this one is not in slope-intercept form. All right, that one is pretty mixed up. This one is in slope-intercept form, so this one's good to go. All right, so we need to fix this one right here. Okay, so to do that, I'm going to write it down below because so it doesn't get all mixed up. Okay, so 2y minus 4x is greater than 2. Okay, so I need to do a couple of algebra steps to make this work. First, I need to get this 4x over to the other side. Okay, so to do that, I'm going to go plus 4x and plus 4x to this side. All right, that'll cancel it there. And I'm left with 2y is greater than, I'm going to put the 4x first, so 4x plus 2. All right, perfect. I got that, and I'm really, really close to it looking like this. The only problem is I have this 2 hanging out with the y, so I need to cancel the 2. Okay, right now it's 2 times y, so I need to do the opposite. I need to divide by 2, and then everything over here also has to get divided by 2, okay? Because that's how algebra works. If we do something here, we got to do the same thing over to the other side. So if I do that, the 2's cancel, and I get y is greater than, this would come out to 2x plus this would come out to just 1. All right, perfect. Now that I got, now we have it in slope-intercept form, so we can graph both of them. So let's start with this one right here. Since this one was first, we'll get this one graphed. Okay, so we'll start at our y-intercept of positive 1. All right, and then our slope, it's a positive slope. We'll put a 1 under that 2, so we got a slope to work with. So we're going to be going up 2 over 1 to the right. Up 2 over 1. All right, we'll put a few points down here. Okay, there we go. And if we take a look, it's going to be a broken line because it doesn't have the equal to part. All right, so this is going to get connected with a broken line here. All right, we'll put some arrows. Okay, perfect. We have that graphed. Now, before we get any further, let's take care of the shading part before I get that other line on there. So the shading, so y is greater than the line. So if we take a look at our y-axis, we want to be shading up above the line because y is greater than the line itself. So all these numbers are getting greater as we go up. So that's what we want to shade. So get your favorite shading tool, and we'll get some shading up above the line. Okay, some nice shading there. Excellent. All right, now let's take a look at our second line and we'll get that one graphed. So our second one, take a look here. This one has the same slope as this one here. So just like we had parallel lines in the last one, we're going to have some parallel lines with this one here. All right, so let's go ahead and graph it. Let's start at our -3 on our y-intercept, -3. Okay, and then we need a slope, so put a 1 underneath that 2. It's a positive slope, same as the other one. We're going up 2 over 1. Up 2 over 1. All right, and take a look. It's parallel to what the other one is. Okay, so we got that. Let's see what we got. Oh, this one's going to be a solid line. Check that out. It has the equal to part. All right, I guess I didn't need so many dots, but why not have extra dots? Okay, there we go. It's solid. So one is broken, the other one's solid. Now we need to do some shading. So we got our lines on there. So the second one, y is going to be less than the line itself. Okay, so y is going to be underneath of the line. So here's our y-intercept, and we're showing y is going to get smaller. So it's going to be everything underneath of this. So we're going to shade. And when we shade, we're going to run into a bit of a situation here. All right, because I'm shading this. As you notice, I'm getting further away from my other shaded regions, so there's no way these two shaded regions are going to overlap. So, interesting how that one turned out. So we need to describe the solutions. The problem is we don't have any solutions because there's no spot where these two shaded regions overlapped. So this is a linear inequality that has no solutions. All right, we have no solutions to this here. All right, so that's what we would put down. There's no spot where those two areas crossed. All right, so sometimes you run into some of those. Okay, try this one out, see how you end up doing with this. Graph these two lines, make sure it is in y equals mx plus b. All right, so you got this one here. This one's good to go. This one you need to change around. Follow the same steps we just did, and you can get that into slope-intercept form, and then see what you can do with graphing that, and we'll check your answers here in a couple minutes. So pause the video, work on that, and then we'll see what you guys come up with. All right, let's take a look and see what you guys ended up with for some answers for this. All right, so if we're going to go ahead and graph this thing, we need them both to be in y equals mx plus b. Okay, so we'll go through this rather quickly. So I need to get this one into slope-intercept form. All right, so I'm going to move 3x to the other side by going minus 3x. Okay, when I do that, I get 6y is less than or equal to, I'm going to put negative 3x first and then plus 12. All right, so it looks like that. Then I need to get rid of this 6. So we're dividing by 6, and then each one of these needs to get divided by 6 also. Okay, so if I do that, that cancels, and you were left with y is less than or equal to, this we're going to write as a fraction, so we have a slope. So this would simplify down to 1 over 2. So we're going to have negative 1 over 2x plus 2. All right, perfect. So I got that one in slope-intercept form. It's ready to go. This one here is ready to go already. So let's go ahead and figure out where it would be graphed. So we'd be starting at minus 7. We don't have a number here for x, so we're going to put 1 over 1. All right, so we're going to be going up 1 over 1, and it's positive. Okay. And let's see, it looks like it's going to be a broken line. Okay, so it's going to look like that right there. Shading, y is greater. So let's get that shaded here right quick. So we're going to be shading up above the line. All right, perfect. Okay, second one, let's get this one graphed starting at +2. And our slope is negative, so it's going to point to the left, and we're going up 1 over 2. All right, so we're going to make this one point to the left side. So we're going to go up 1 over 2, and looks like it is a solid line that we're going to end up graphing. Okay, so let's get that connected. Nice solid line there. Excellent. Okay, so that one should look like that. All right, and then now we want to do some shading. So y is going to be less than the line. So here's our y-intercept. We're going to shade everything below this line here. All right, so we'll get some shading done. And we have a nice area that's overlapping, so that's good. All right, perfect. We got that finished. Okay, we got a nice big region where those two colors overlapped, which is great. All right, so now we can do like what we did in our first example. We're going to name 2 ordered pairs that are solutions and 2 that are not. Okay, so I'm going to put down yes. Find 2 points that are solutions. We got any of these points in this region would be fine. Okay, we'll go with those 2 points. Name those. Let's see. We would have 1, 0 for that one. All right, and you probably name some different ones. That's fine. You don't have to name the same ones I do. All right, and then we also have -7, 3. Okay, there's a couple of yeses. Let's take a look at ones that wouldn't work. So this guy, that's one of them that doesn't work. And we could go with this one down here for another one that's not going to work. All right, so let's name those 2. We have 4, 1. And another one here, we have 7, -3. All right, perfect. We got that one solved. We got it graphed, and we found 2 that are solutions and found 2 that are not solutions. All right, so check that. Make sure that ended up with what you had. Make any corrections that you need to. And then let's take a look at one more thing we're going to do. All right, instead of graphing, what we want to do is check to see if an ordered pair that they give us is going to be a solution to this linear inequalities. Okay, so we're just going to take this number for x and y, we're going to plug it in, and we're going to test it to see if it makes a true statement. Okay, so let's take a look at our first one here. So we're going to take this equation, we're going to put in x and y into this and see what we get. Okay, so if I take that one, my y is -3, and keep that same symbol. And then I'm going to have -3 times x, so -3 times -1. And then I have +1. Okay, now you just got a little bit of math to do, and you're going to see if this ends up being true. So -3 is less than or equal to, that would come out to +3 plus 1. So -3 less than 4. All right, we did all the math. Check to see if it's a true statement. It is. -3 is less than 4. So it works out. The first one is good. Now we got to check the second one and see if it is also going to work out. And if it does, this would mean this is a spot that would fall into the blended shaded regions if we were going to graph it. Okay, so let's put this in here. So we have -3 for y, so -3 is less than 2 times -1 plus 2. All right. Now we'll go ahead and check this, run the math. -3 is less than, this would be -2 plus 2. Okay, and then we get -3 is less than 0. All right, check it to see if it's a true statement. It is. -3 is less than 0, so check, and this would be a yes. All right, these end up working out to be an ordered pair that would be a solution to this. So if we graphed these two lines, this would fall into that blended shaded region is what that is telling us. All right, I'm going to have you guys try one on your own, see if you can test it to see if it's going to be a solution or not. All right, so try this one, see what you come up with, and then we'll take a look and see what you get for an answer to it. So pause the video and then hit play when you're done. All right, let's take a look and see what this would come out to. Okay, this one, ordered pair, is not going to be a solution to the system because it doesn't make true statements. We can check it right quick. All right, we got our x and y, so let's plug that in. So for our first one, we have y is less than -2 times -1 minus 1. All right, so then if we work that, 5 is less than 2 minus 1, and 5 is not less than 1. So our first one doesn't check out at all, so we can automatically say no because they both have to work, and our first one didn't end up working, so that's why it doesn't come out to be a solution. All right, so hopefully that's what you got too. If you got stuck on any of these, the graphing or doing this part here, let me know. Your guys' assignment today, it's in Google Classroom. It's a 5.5 worksheet. Work on that, see how that goes for you. Let me know if you got any questions. Thank you guys for watching.